guys, welcome back to HVAC official channel. Today we are talking about one of the most advanced HVAC technologies, VRF Systems, Variable Refrigerant Flow. Guys, if you want to work in commercial HVAC, hotels, hospitals, office towers, shopping malls, you must understand VRF Systems. Today, I will explain everything. What is VRF? How it works? Types, advantages, disadvantages. 100% correct information. Let's go. What is a VRF system? A VRF system is an HVAC solution where refrigerant acts as the direct heating and cooling medium. The system consists of an outdoor condenser unit connected to various indoor units via a network of refrigerant pipes. Now guys, let me make this even simpler. Think of VRF like a smart water supply system in a building. One main pump, pumping water to every floor. But each floor controls exactly how much water it needs. Same thing with VRF. One outdoor unit supplying refrigerant to multiple indoor units. Each indoor unit getting exactly the amount of refrigerant it needs. No more, no less. VRF technology regulates the amount of refrigerant sent to each indoor unit, maximizing energy efficiency. This is the key difference from regular split AC systems, guys. A regular split AC compressor runs at fixed speed, full on or full off. VRF system, compressor adjusts speed continuously, giving each zone exactly what it needs. VRF was initially developed in Japan by Daikin in 1982, originally called Variable Refrigerant Volume, VRV. Daikin still uses the VRV name. All other brands call it VRF. Same technology, different name. How does a VRF system work? Now guys, let me explain exactly how VRF works. Step 1. The outdoor unit. The outdoor unit contains one or more large inverter compressors. DC inverters are added to the compressor to support variable motor speed and thus variable refrigerant flow, rather than simply on/off operation. This inverter compressor is the brain of the VRF system. It constantly adjusts its speed based on the cooling or heating demand. Step 2. Refrigerant distribution. From the outdoor unit, refrigerant travels through copper pipes. These pipes branch out to every indoor unit in the building. Branch joints, or refrigerant branch controllers, distribute the correct amount of refrigerant to each indoor unit. Step 3. Indoor units. VRF systems move refrigerant directly to each indoor unit, adjusting the flow based on real-time demand. Each indoor unit has its own electronic expansion valve. This valve controls exactly how much refrigerant enters that unit. If one room needs more cooling, valve opens more. If room is already cool, valve reduces flow. Each room is controlled independently. Step 4. Zone control. VRF technology is like cruise control in your car, intelligently adjusting speed for optimal performance and energy savings. If one zone needs cooling and another needs heating, the system handles both simultaneously. This is called heat recovery VRF, the most advanced type. Types of VRF systems. Guys, there are two main types of VRF systems. Type 1. Cooling-only VRF. This system only provides cooling. One outdoor unit, multiple indoor units, all cooling. Used in hot climates where heating is not needed. Perfect for Pakistan, Dubai, Saudi Arabia. Type 2. Heat recovery VRF. Most advanced. VRF technology allows for simultaneous heating and cooling in different areas of the same building. Imagine this, guys. The south side of a hotel building faces the sun, needs cooling. The north side is in shade, needs heating. Heat recovery VRF handles both at the same time. It takes heat from the areas being cooled and transfers it to areas that need heating. This is incredibly energy efficient. No energy is wasted. Heat is recycled within the building. Systems selected with a heat recovery module have the benefit of simultaneously heating and cooling from one condensing unit, transferring energy between zones. This is why VRF is so popular in large commercial buildings worldwide. Main components of VRF system. Guys, let me quickly explain all main components. Component 1, outdoor unit. Contains the inverter compressor, condenser coil, and outdoor fan. One outdoor unit can connect to up to 50 or more indoor units, depending on the brand and capacity. Component 2, refrigerant branch controller. This is unique to VRF systems. It is a junction box where refrigerant pipes branch out to individual indoor units. It controls refrigerant distribution to each zone. Component 3, indoor units. VRF systems support many types of indoor units: wall-mounted units, ceiling cassette units, ceiling concealed units, floor standing units. Each indoor unit has its own electronic expansion valve. Component 4, central controller. VRF systems maintain optimum volume of refrigerant to each indoor unit, utilizing inverter drives on compressors, supplying just enough heating or cooling. A central controller manages all indoor units from one screen. Building managers can control the entire system from one place, set schedules, monitor temperatures, check energy consumption. Advantages of VRF system. Guys, VRF has many amazing advantages. Advantage 1, incredible energy efficiency. A VRF system can produce up to 40% more energy efficiency than a traditional HVAC system. Because compressor only works as hard as needed, no energy is wasted. Advantage 2, zone control. Every room controlled independently. One person wants 20 degrees, another wants 26 degrees. Both get exactly what they want, simultaneously. Advantage 3, no ductwork needed. VRF is a ductless HVAC system. No need for extensive ductwork. This saves construction cost and space. No energy lost through leaky ducts. Advantage 4, very quiet operation. VRF systems use inverter compressors, allowing the compressor motor to run at variable speeds to save energy. Variable speed means smooth, quiet operation. No sudden on/off noise. Very quiet for hotels and hospitals. Advantage 5, simultaneous heating and cooling. Heat recovery VRF can heat some zones while cooling others at the same time. No other HVAC system can do this as efficiently. Advantage 6, long piping distance. Refrigerant can travel very long distances in VRF systems, up to 150 to 200 meters from outdoor to indoor unit. Perfect for tall buildings and large floor areas. Advantage 7, easy expansion. Need to add a new room? Just add another indoor unit to the existing system. No need to install a completely new system. Disadvantages of VRF system. Guys, I always give you honest information. VRF also has some disadvantages. Disadvantage 1, high installation cost. VRF systems are expensive to install, much more than regular split AC systems. However, Energy savings over time recover this cost. Disadvantage 2. Complex installation. VRF installation requires highly skilled and trained technicians. Wrong installation causes serious problems. A single contamination or sizing error cascades into charge problems, capacity loss, or compressor failure. Always hire certified VRF technicians for installation. Disadvantage 3. Refrigerant leak risk. Since refrigerant pipes run throughout the building, a leak anywhere affects the whole system, and refrigerant leak detection in VRF systems is complex. Disadvantage 4. Expensive repairs. If the outdoor unit or inverter compressor fails, repair cost is very high. Spare parts are expensive and not always available everywhere. Where is VRF used? Guys, VRF systems are used in hotels. Each room gets individual temperature control. Hospitals, precise temperature for every ward and operation theater. Office buildings, different zones for different departments. Shopping malls, efficient cooling across huge floor areas. Residential apartments, luxury apartments with zone control. Data centers, precise temperature control for servers. In Pakistan, VRF systems are becoming very popular in large hotels in Karachi, Lahore, Islamabad, commercial office buildings and plazas. VRF versus split AC versus chiller. Quick comparison. Let me give you a quick comparison, guys. Split AC, one outdoor, one indoor, one room only. VRF system, one outdoor, multiple indoors, multiple zones, zone control. Chiller system, uses chilled water, no refrigerant to rooms, needs AHUS. VRF, no ducts needed, refrigerant pipes only. Chiller, needs ducts or fan coil units in every room. VRF, best for medium to large buildings needing zone control. Chiller, best for very large buildings with massive cooling loads. Guys, now you completely understand VRF systems. VRF, variable refrigerant flow, one outdoor unit, multiple indoor units. Refrigerant flows to each zone as needed. Inverter compressor adjusts speed continuously. Each zone controlled independently. Two types, cooling only VRF and heat recovery VRF. Advantages: energy efficient, quiet, zone control, no ducts. Disadvantages: high cost, complex installation, expensive repairs, used in hotels, hospitals, offices, malls. Master VRF knowledge, and you open the door to the highest paying HVAC jobs. If this video helped you, please like and share. Share with every HVAC student who wants to level up. Subscribe to HVAC official channel.